Yes, sir. You can start, sir.
Okay, thank you so much. Very nice of you for a good introduction of me. Thank you very much.
Thank you, sir.
Okay. So, good afternoon, everybody. Welcome to this afternoon presentation. I will be talking to you today on challenges in communication technology for smart meters employed in smart cities. So, before we start the presentation, just let us chant the Bhagavad Gita shloka, which will purify our mind, our soul, and our spirit. Also, we are entering into the knowledge domain today. So, knowledge also should get purified. The shloka is like this: Nahi gnanena sadrusham pavitram iha vidyate tatsvayam yoga samsiddhaha kalen atmani vindati. There is nothing better than knowledge which can purify your mind, your soul, and your spirit. So, knowledge purifies. So, with this shloka, we will start today's presentation. And the presentation focus is mainly on the communication technology employed in smart metering system today. I think before that, we would like to have a small introduction about the concept of smart city. To facilitate a smart city, smart infrastructure such as smart transportation, smart electricity, smart communication, or basic needs. So the proposal of smart cities in India has already begun in a big way, which includes better way of urbanization. For smart electricity, smart grid is a basic requirement. Smart meters is an essential part of smart grid. Smart meters are the key component in smart city. So we are going to discuss today about how smart meters will help in making our energy consumption as well as metering system smart, and how smart communication technology helps to support the smart city infrastructure. So the concepts of smart city and smart grid and how they are dependent on smart meters will be focused here in my presentation, with a special emphasis on communication technology, which is the heart of smart city project. So smart meters have brought big revolution in the field of energy and power management, power measurement especially. Worldwide, at so many places, smart meters have already been deployed in a very big way. But in India, it is just starting. The deployment of smart meters in a very small way we have started. So in our presentation, we discuss the role of communication technology for supporting smart meters in smart grids employed in smart city project. So with this introduction, we will just start our presentation. The main focus here is on the mass rollout program and also the communication technology, and also the main focus is on the what is happening today not only in India but also in overseas about the smart meter incorporation, adaptation, testing, and also how this communication will help in providing the smart infrastructure to make the city, a grid, a smart grid, a meter, a smart meter. So this is how we start our presentation. I think you can see this slide. This slide is about the transmission and distribution of electricity in an environment. As you can see here, the right portion, you can see this is a power plant, transmission substation, high voltage transmission line, power substation, transformer for the power station, substation, and then power lines that will be distributed to the house which uses electricity. So although the whole system is electrically connected, the power plant is connected to the transmission system is to the distribution is to the power line management, and then to the house. The whole thing is in the electrical network, but it is not communicated. The first end, second end, and third end, they are not communicable. To make it the communication system embedded into the whole arena of this particular measurement of technology, we have to understand how this particular technology could be integrated into the electrical network. So, to make the whole grid a smart grid, the communication is an essential feature. So, we have to now see how this particular communication is being governed in the system. This is the analogy to the human body. So, a smart grid intersects the electrical grid with automation, communication, and IT system, information technology system, that can monitor power flow from point of generation to the point of consumption, even down to the appliance level. Each appliance is smart enough and control the power flow or curtail the load to match the generation in real-time management. You can see that smart grid technology is a convergent technology. It has mainly three layers: the physical layer, the communication layer, and the information technology layer. The physical network is the electrical network prevalent today. The communication is embedded into the system. The information technology is also inculcated to see that the grid becomes a smart grid. The human analogy is very important. Human body is already a smart body. It accepts everything. In fact, as you can see here, the physical network, the existing electrical grid, where the analogy is it is related to the muscle power. The muscle power is termed in megawatts, or it carry megawatts. Whereas the communication system is analogous to nervous system in the body, which carries megahertz. As the information technology is analogous to human brain, which carry megabytes. That means to say the human body sends signals to different part of the body to make it an aligned system. Whereas the smart grid also is getting aligned. The existing grid with the communication infrastructure, with the information technology alignment, will become a smart grid. And as you know, smart grid is the most essential part in the smart city project. Whereas the smart meter is one of the most essential parts of the smart grid. So one is intertwined to the other. One is connected to the other, electrically, communication wise, information wise. So this is how I start with presentation. Okay. Are you clear, sir?
Yes,
Very
sir.
nice. So smart grid needs secure communication. This is a model conceived by NIST, National Institute of Standardization and Testing, which is an institute in USA contributing mainly to the research and development of the electrical network and electrical philosophy. So it has 7 domains: generation, transmission, distribution, and custom, as you can see here. Okay. So the domains, electrical domains, are connected in a dotted line, as you can see. Whereas the market, operation, and service provider, they are connected by secure communication flow line. So that means to say the generation, the transmission, the distribution, and the utilization customer point, they are connected not only electrically but also with the communication system. So the communication system will also answer so many prerequisites of the smart grid. So we will see how the smart grid will enhance the application of the present electrical grid in terms of the convergent technology upgradation exercise, which has happened over a period of time. So now the meter, what I'm going to discuss is here, the customer end, and also I'm going to discuss, the pros and cons and adaptation technology, how this works in the energy meter principle, which is being used in the smart meter communication flow. So with this, we will start our presentation with the concept on what is known as the communication architecture. And you have here the four domains: the generation, the transmission, the distribution, and the customer premises. And you have here the generation, the power plant, which produces the power, maybe a distributed generation or a centralized generation. Centralized generation is nothing but your coal waste, etc. Whereas the distribution generation is nothing but the inculcation of different generations into the generation principle to make it the generation a smart generation. For example, DERs, distributed electricity generation, it will make it the generation a smart generation. Incorporation of solar energy, wind energy, biomass energy, etc. It will make the generation a smart generation with the incorporation of communication network and also with the incorporation of the information technology. Similarly, the transmission system will have field devices, the distribution system will have field devices, and customer premises you have the meter and the load. Okay, so this is integrated into communication network. And finally, we have here the control operation center. Let us enlarge this figure, how it looks when the grid becomes a smart grid. Let us see in the next slide. As you can see here, the whole thing, the electrical utility communication architecture is given here. As you can see here, the generation, it has different generation modules. For example, energy resources like the power plant, stationary, or the solar, wind, biomass, etc. Transmission system has undergone several changes over a period of time. High voltage DC transmission has come in to reduce the losses. And also, the FACTS is another thing, the flexible alternating current transmission system. So like that, we have added synchrophasors and also the wide area network systems, PMUs, to make it more aligned to the present technology and to make the smart system transmission in the inculcation and adaptation of the transmission network. In the distribution management system, we have the field devices, maybe the automation SCADA, and also the other things like substation automation, which will enhance the total applicability and application of the distribution management system as a whole. In the customer management system or the customer premises, we have the smart meter, consumer electric product, energy management system, etc. Now, there is a third party services which provides the energy service provider. So, the communication system here will be regional, or it may be wide area network. We call this as WAN, or it may be a backhaul WAN that is backed up by the WAN system, wide area network system, and it is linked to the field area. That means when it goes to the field management system as such, FAN, that is the field area network, and it is linked to neighbor area network. Neighbor area network is NAN, we call, and then it goes to the home area network, we call HAN. So that means to say we will now discuss the consequential things of the communication technology, which is adopted in the smart grid and smart meter management system to make it more versatile, adaptable, acceptable, and system integrated, to make it more reliable to a system where the architectural plan is totally in line with the present day grid management system, what we call. So we will see now, we have different protocols. I think in the previous slide, you can see here, I have discussed HART. What is HART? We will see. And Profibus, that is, the field bus, the process field bus, and Modbus. These are all certain architectural things which we are going to talk a bit, and then we will move on to the main system of discussion. The HART communication protocol, it is known as Highway Addressable Remote Transducer. It's a hybrid analog digital industrial automation protocol. So its most notable advantage is that it can communicate over legacy 4-20 milliamps, 4 amps input, 20 amps out, milliamps output, analog instrumentation, and sharing the pair of wires used by the analog host system. So this is one of the systems which is used actually as a field device to nutshell the entire management of communication. So we will see how the communication technology in a nutshell is discussed. In fact, as you know, smart meter measures energy usage at different time intervals and transmit measured data to utility through communication technology network. Okay, so this infrastructure, it will provide a very reliable, efficient, and secure power supply to the consumer, and it reduces the cost of electricity. Smart meter, as you know, it does not need the internet to communicate. Instead, they work by what is known as using two wireless networks. I told you in this previous slide, the HAN, the home area network, the WAN, the wide area network. So this network is used to allow your smart gas electricity meter to communicate with each other as well as with your in-home display. What is in-home display? In-home display is an adapter, is a system along with the smart meter which is totally giving you the information flow of electricity consumption, rate, etc. at your choice. So it is kept either in your room or your kitchen or your bathroom just to manage, how much electricity you are using. This is supplied along with the smart meter as an additional adapter. So inside the home, smart meters usually use, the wireless signal at about 2.4 gigahertz with a maximum power of less than 1 watt. That means to say the entire system is coming into picture now as known as the self loss of the system. So this is similar to the frequency to several existing wireless technology like Wi-Fi, Bluetooth, Zigbee, for example. I think we are clear. Now we can proceed. What is the global scenario versus Indian scenario in the smart meter management today? The global smart meter total will rise from 665.1 million in 2017 to more than 1.2 billion by the end of 2024, according to a 2020 report. This is the report which I have collected actually from the internet. So India needs total smart meters 255 million in numbers. That means the existing population of the Indian electricity meter today is 255 million. The percentage of smart meter in India so far is less than 1% as on day. So this is very, very bad situation compared to other countries. However, we are working strongly in an environment where we can definitely surpass the international scenario also. So coming to the operational things, which will have an impact on the overall scenario of the smart metering system in corporation. Number one is we are conducting a lot of pilots, and pilots will give us a lot of results. And based on that, to strengthen our capacity, to strengthen the knowledge based on particular philosophy of operation, we are conducting these pilots to make sure that the reliability of operation is not in jeopardizing situation when mass rollout is happening. So that is the main thing and main focus. Layers of communication. In fact, the communication network of a smart grid has a three-level hierarchical structure consisting of HAN, NAN, and WAN. So wireless communication, due to its advantage, is identified as a total potential candidate for smart grid communication, especially in the HAN and NAN environment. As you can see here, the wireless transmission is inherently unreliable because it has several disadvantages when it comes to the question of incorporation. Whereas the communication reliability is one of the basic fundamental requirement of smart grid application. Because communication fails means nothing will work. So a two-layer communication model based on IEEE reference grid is considered for a non-NAN method, that is neighbor area network method. Based on transmission redundancy, it is proposed to improve the reliability of wireless communication in NAN environment, while the communication delay requirement of the smart grid is considered as a restriction. Okay, so this is how the whole scenario is being adopted for the management. So now the requirement of smart meter communication network is very important. There are 5 major requirements. One is transmit and collect data reliably from each meter, ensure the data security, maintain and manage the communication network effectively, continue running of a long time, construct and maintain at low cost in the sense how to optimize the cost. That is very important from the discussion also today. So these requirements are to be borne in mind when we think of smart communication in the smart metering system. Okay, so the most essential thing here is the security of data, collection of data, maintenance of communication network, and also running for a long time, that is a stable application, and construct and maintain at low optimal cost. This particular extract is very interesting, and this is taken from Landis and Gare. Landis and Gare is one of the world famous meter manufacturers located in Switzerland, and their incorporation and their technology is taken as the baseline for the whole world actually, because they're number one in the energy meter management system. This is taken from LinkedIn. Most of my presentation are focused on LinkedIn actually. They are taken from LinkedIn because LinkedIn gives you the updated information where it is possible for us to really get the knowledge based on what is happening around us. So smart meter communication, there are 3 things. One is smart meter, second is a router, third is a collector. So smart meter, we use it as a traffic generator. That means it generates the traffic, particularly with regards to an assigned value with a global IPv6 address, Internet Protocol version 6. It receives demand response data from the collector. So very important. Router is one thing which takes the responsibility of relaying packets from both smart meters and collectors. It determines the next hop for the packet to reach the final destination. Collector collects the data. It serves the interconnection between a NAN and a WAN, that is the neighbor area and wide area, in the smart grid domain. Collector node collects all meter reading data and sends acknowledgement back to the corresponding meter. So this is how the smart meter communication happens. I think this is a very important slide which gives you the gist of what I'm going to talk in another 35 minutes. Okay. Let us understand the block diagram of a smart meter. Smart meter comprises of 2 parts mainly: metrology part, communication part, or we call metrology board and communication board. They are integrated actually. The metrology board consists of a microprocessor, an LCD display, a connection and disconnection switch, which is inbuilt into the meter. This switch is of 100 amps capacity, which will throw open the circuit or it will disconnect the circuit when the load management is not happening properly. So it has an internet port. That is, it has an infrared port actually and a power supply. The infrared port is used for calibration purpose, and also it is used to check the signals. Whereas the communication board has a microprocessor controller, a NAN communication module, or a HAN communication module. It is built in depending upon what you need to be done in the system. And it is powered by a power supply. And this is how the smart meter works. The functions are very important for a smart meter. In fact, the smart meter, it provides various information. For example, it measures the power quality, it controls remotely the data, it provides a TOU and TOD tariff, time of use and time of the day tariff. It provides real-time communication. It provides, the distributed generation where it accommodates even the solar energy, wind energy, biomass energy, and it can measure accurately, bidirectional in any quadrant. I will tell you what is that actually. Remote programming, possible to program. It provides a demand-based tariff, and you can program it, and service switching. That means, the switching operation can be done while in service to focus on what you need to be done. Billing by smart meter without smart reader. How your smart meter helps to take charge of your power bill. Your smart meter measures and records electricity usage every 30 minutes, or you can program it even 10 minutes also it can measure. So the data is transmitted to electricity distributor who owns and manage the grid and wires. Then it goes to the energy provider. It makes consumption data available to you via web portal or in-home display. I told you IHD. In-home display, as I told you, is an adapter, is a system integrated into smart meter and also it is sold as a total package system for you. And you can monitor your household energy usage to help compare offers, better manage cost, which is very important in the market today because the cost of power is also varying, like your Sensex value, like your mutual fund value, which varies, gold value, dollar value, whatever you take. The power is a very, very essential commodity. And you may not store the power, but you can use it as it comes. But storage technology also is coming up in a big way. That is not the purpose of this particular presentation. But I would like to focus more on the smart meter philosophy. And also I would like to focus more on the communication technology, how this particular thing has evolved into smart city project. Let us understand briefly how smart meter works because we have to proceed for further discussion. I think there are 6 major things actually to be discussed here. Number one, the smart meter, it measures consumption of energy and it provides information on power quality. And also, it measures not only the electricity consumption, but gives you an indication how you are using your electricity over a period of time. Okay. The data is transferred via power line carrier, that is PLC, mobile network, and radio wave to the smart metering system at the energy utility. The data is collected to the head end system, we call HES, and head end system is nothing but a computational system management and further processed in the meter data management system. This is known as MDMS, which is a software. So MDMS accepts data from head end system. Head end system collects the data from the smart metering system. I will tell you how sequentially how it comes in the coming discussion. So the data is forwarded into further IT system. The IT system, I told you, is one of the creams in the smart metering application. For example, the customer information system, this is known as CIS, is IT. The distribution management system is known as DMS. This is nothing but your IT system. So the fifth one is very important. Metering data is used for billing and customer service to provide accurate rather than estimated bill. Today, your bill may be estimated, but accuracy is very important with which, because you are using electricity, which is a precious commodity today, and the consumer consumption records. Utilities receive regular updates on the status of the electricity network and power quality report. So the utility can send on demand request for meter reading as well as control power supply or individual loads in the household. So the end consumer receives bills based on actual energy consumption. So they're able to follow their individual consumption pattern through a portal or in-home display, as I told you. So this IHD is also an important event, in the smart management system for the smart metering application. So real-time data is available to the utilities consumer service personnel, which improves service through streamlined, efficient processes. Example, when the customer moves house, the smart metering solution can provide an interface to home energy management system. This is one of the architectures of the smart communication in the smart meter. As you can see left, this is a bidirectional communication. As you can see, double-headed arrow is a bidirectional communication. So array of smart meters are connected here through LAN, collector, WAN, and application. The LAN may be a PLC, power line communication, point to point, maybe a mesh connection, maybe a hybrid connection. Okay. The collector may be towers, repeaters, neighborhood substations, etc. The WAN may be telephony, broadband, radio frequency, fiber optics, whatever it is. That is actually, we will discuss everything thoroughly. Don't worry about it. Applications consist of MDMA, the meter data management agent, billing system, outage management system, and also the distribution automation, which is the final applications in the smart architecture, where the communication plays a major role in the smart meter communication architectural diagram, which I have shown here today. The second thing is also another structure, another architecture, another model. These models are nothing but the models which are being considered for our application, and internationally these are used in a big way. The smart meter as such, you can see here. So this is the metering part, and the blue line is nothing but the communication system, and the operation management system is shown at the right extreme actually. So the smart meter, the communication system may be different. It may be RF based through a field area network in a PLC mechanism maybe, or it may be a fan that is the field area network on a 3G network, or it may be a WAN cloud. Finally, it will go to the head end system, computational management, where the RF communication, PLC communication, 3G communication, they are integrated into the head end system, and it gives the data, and it goes to the meter data collection. It collects the data, validates the data, and gives the data to the MDMS. And MDMS, you can arrive the data, which does the meter data management system, smart meter equipment management system, network management system. They are all linked actually to the main system operation management, where the system linkage platform is very essential to understand the configuration of the architecture. So these are all certain international models which are available for discussion, and then probably we can discuss more about it as we come to the question of answer session. Okay, WAN and FAN. This is very important. I think probably what we'll do is we will go through the presentation and we'll keep all the questions at the end. Probably by about 3:40, we will try to finish the presentation, and then we will focus on question and answers. Okay, because this is a very lengthy subject, and you have to focus on this, and also you have to be attentive to understand, because each is cascaded to the next actually. So that is how I want to build the whole arena of understanding of a smart communication in a way which is possible for us actually to confine. Okay, so this is WAN and FAN system. In fact, here utility company is the consumer, bidirectional communication. You have here BPL, that is the broadband or power line network, fiber optic, wireless, and you have here the concentrator, which concentrate data concentrator, and then goes to the either FAN, that is field area, where you have the smart meter in the home management system, shop management system, like the wireless connection for the smart meter, and here the factory, that is actually you can the consumption pattern depends upon the load also, as you can see here. This is how the WAN fan arrangement for the communication system is being integrated into the domain of smart metering arena. This is the topology in communication. This has two things, mainly private realm and the public realm. And you have here the meter management, data management system, LAN, this is WAN, this is NAN, this is HAN, home area network. In the home area network, you have the smart metering system. As you can see here, the smart meter is coming in this particular, as you can see here. Okay, this is where the HAN into the different protocols are being discussed. In the LAN, you have the fiber optic, maybe. In the WAN, you have WiMAX, satellite communication, cellular communication, etc. Whereas in the NAN, you have the WiMAX, cellular, Wi-Fi. We will discuss all these things, don't worry. We will discuss everything with regards to the operational characteristics, or maybe PLC. NAN may be a ZigBee or a PLC or a Z-Wave, depending upon what you need to have in the system. Okay, this is interconnected into the load domain, like the energy storage management system, smart home management system, smart thermostat management system, like that. It has different load structures with which the meter is integrated into the communication topology. I think this is a very, very important slide. Understand this very clearly, how the configuration of LAN, WAN, and NAN, HAN will make the whole communication system integrated into one domain, what we call as the measurement domain and the communication domain, with which it is possible for us to assess the total consumption pattern of a system, particularly with regards to load management and operational management. Okay. Communication technology for smart meter comprises of different technologies like the PLC, the GPRS or 3G, the Wi-Fi and Wi maximum, the radio frequency, the LAN and optical fiber. The advantages are given here. Okay, for example, PLC may be secure, infrastructure, no data charges. Okay, the main disadvantage is length of line, and also the signal to noise ratio is very high in this protocol. The GPRS, it's reliable, capacity is available for 6 million consumers, maybe more than that actually. High OPEX cost, some areas are not covered actually. Operational cost is very high here. Y maximum, low OPEX cost, coverage only in main cities. Radio frequency, low OPEX using free frequencies. Free means licensed. Licenses may not be required actually. I will tell you the licensing and other things when it comes to the question of discussion, the ZigBee management, etc. Okay, it is susceptible to strong noise, sensitive to obstacles. It could be subjected to license cost. Okay, LAN, it may be an optical fiber. Operation cost is less actually, very less. Need to have a dedicated cabling system in the entire management. Okay. So this is once again taken from LinkedIn, and this is based on what we call advanced metering infrastructure, AMI. This is a part of smart meter actually. The AMI communication technology, it builds the connectivity for smart meter information. This is from Landis and Gale, the world famous meter manufacturer. As I told you, the communication in the next left profile, and it goes to the AMI infrastructure and advanced meter management, we call AMM, which is the next stage of AMI. So we have used here the local area, the wide area, the neighborhood area, and also the home area management. And each is given its importance for the application. For example, in the local area network, you have several infrastructure, and then in the wide area, maybe GPRS, maybe UMTMs, that is Universal Mobile Telecommunication System, private wireless, broadband over power line, WiMAX, LTE, long-term evolution that I will discuss actually. That is 4G based platform. Okay, neighborhood area, we have here PLC, the OFDM. OFDM is nothing but your orthogonal frequency division multiplexing. Okay, FFTH, that is the fiber. And in the home area, you have ZigBee, Z-Wave, 6LoWPAN, that is nothing but the latest technology on the version, as I told you. This is nothing but your main discussion of the day, and I'm going to focus more on this particular thing as I go ahead with the presentation. Okay, so we will see further This is a very important aspect to be discussed actually. LinkedIn 2020 December, it has appeared. Smart meters measure electricity usage and communicate this information back to the supplier using what? Short burst of radio waves or low level radio frequency, electromagnetic radiation, EMR. So Health Canada has conducted lot of tests both in the laboratory as well as in the field, and concluded that exposure to RF energy from smart meter does not pose a public health risk. You can see more actually in this links which I have provided here. Probably this will be helpful to you to go into the details of the health management, which is a very essential factor in the smart city management also, because the wherever we go, communication, wherever we do, the entire measurement, entire thing is linked to what we call the electromagnetic radiation with regards to either even mobile phone, smartphone, whatever it is. Particularly, it will add to the agony of this particular linkage mechanism. Therefore, we don't have to worry about this, as the lot of research has been conducted in this particular area. Health wise, it will not have any impact. How to address the communication challenges of smart meters? We have here the building management, wide area network, in the neighbor area network, and home area network. And we have clusters of communication in each particular entity discussed here. Maybe in the WAN, it is 3G. In the NAN, it may be PLC or 802.15. I will talk to you more about it. In the HAN, we have a ZigBee protocol. In the building area, it may be a Threadway, Wi-Fi, Bluetooth, ZigBee, whatever it is. That I will talk to you as I proceed further. You can see here, this is BPL, broadband over power line, metro fiber ring architecture. This is a live actually. You can see it sends signal. The signal goes right side the residential home, left side the business undertaking, and also the transformers, which gives you the necessary support for the electricity management with the communication infrastructure, so that the internet, the data, and also the purpose of this particular thing is to provide a stable communication system, a stable 24 bar power system to the grid, so that the city becomes a smart city. This is a legacy system where the consumer, the meter, the utility, it is one directional. As you can see, consumer to meter, meter to utility. That's all. It is one directional, one way communication. Whereas the whole ambit of this particular thing will have an impact on the bidirectional communication with the advanced metering infrastructure. As you can see here, the HAN, smart meter, RF cloud, CDMA or GSM, meter data management system, utility. This is how the two-way communication is built in to the entire mechanism of smart grid arrangement with a smart meter, how it plays a role, in the energy management structure. These are all the security challenges in smart meter architecture. As you can see here, this is the SSL, that is the secure socket layer. Security is very important because the cyber attack may happen because of electronics, because of communication, because of information technology. It is as similar to what you are using in your present day system. So this is how the Wi-Fi, meter number 1, meter number N. This is how Wi-Fi, ZigBee, PLC, etc. This is a data concentrator which concentrates the data. And here, it is PLC, internet, Wi-Fi, satellite, 4G, LTE, whatever it is, to be given to the utility company in the data center management. This is how the security is provided actually in the smart metering architecture. The communication components, they are considered actually technology. We have here what are all the main benefits, what are all the challenges. I think probably each technology is having its own benefits and its own advantage and its own challenge. As you can see here, the cellular, wireless, hardline, and then BPL and PLC, broadband over power line, or the power line communication system will have its own benefit, which is given here in the slide, and probably it have its own challenges. I don't think we need to discuss this as we proceed further. All these things will come as a concurrent discussion for the challenging application of the communication infrastructure as a whole. The communication opportunities and challenges we will see one by one. Communication technology for smart grid, particularly on smart meter also. Wireless communication technology. It is IEEE 802.154, Z-Wave, IEEE 802.11, IEEE 802.16, or it may be LTE or advanced version of LTE, that is long-term evolution. What you are using today, the 4G by Vodafone in India, is conforming to the LTE system. Okay, and next is IEEE 802.22. So this is another important factor where we have to consider these wireless communication technologies. So when it comes to the question of understanding, the communication technology for the smart grid further, the wired communication technologies are different. That is, one is the power line PLC, which conforms to IEEE P1901. That is, BPL, or ITU TGHN we call, or ANSI CEA 709 specification. ITU is nothing but your International Telecommunication Union, and GHN is the name for the upcoming wireless home networking standard developed under the umbrella of ITU. And wireline communication technology, like the fiber optic communication, Ethernet communication, they are all the latest things which are adopted for the purpose of wired communication system in the smart grid arrangement, which will be enhanced for the smart metering application also. IEEE 802.15.4 is the Zigbee. We will tell you more about Zigbee afterwards. Zigbee is a short range, low data rate, energy efficient wireless protocol. So Zigbee utilizes different channels, 16, 13, or one channel in different frequency in different application area. For example, 2.4 gigahertz in ISM bandwidth. ISM is industrial, scientific, medicine, which doesn't need licensing. Okay. Zigbee Smart Energy Profile, that is SEP, aims, it supports the need of smart metering and advanced metering infrastructure. And it provides communication among utilities and also household devices. You must understand here very important thing. Each and every household appliance, whatever you are using today, should have a communication system, a chip embedded into that. For example, it may be a smart heater, smart geyser, smart washing machine, anything what for that matter. It should communicate with the meter with the chipset, whatever is provided. Then only the whole alignment of the system in the communication technology for smart meter becomes a reality. Very important. What is 3G, 4G cellular? You know that what is actually basically 2G? 2G is actually the global system for mobile. That is the world system, which is totally getting depleted today as far as technology is concerned. 3G is UMTS, Universal Mobile Telecommunication. Okay. So 4G is the present one. The range is 824 to 894 or 1900 megahertz. License frequency band, hence expensive. Mobile can receive data over serial or Ethernet interface and transmit over second interfaces. Okay. The main advantage is number one, the SCADA interface for remote distribution. CDMA for power system SCADA provides cellular communication between the RTU, the remote terminal unit, and SCADA server. That is how the distribution automation system also is an employment for the smart meter application. So we will first further discuss what is actually the 3G and 4G. In fact, for maximum compatibility for most carriers, the 2G, 3G, 4G platform, the minimum dual band 800 megahertz cellular or 1900 personal computer communication system is generally recommended. In many market, that is 4G data, like the LTE, WiMAX is on 700 megahertz, 1700 to 2100 megahertz, 1900 megahertz, and 2500 to 2700 megahertz. So the 4G LTE wireless LTE is the latest thing, in the 4G category. Okay. The wireless broadband is 10 times faster than the 3G. Okay. So let us focus on this particular 3G, which will have an upload spectrum between 2 and 5 Mbps with a peak download speed approaching 50 Mbps. Okay. In fact, in a report, the International Telecommunication Union, they outline 13 specifications that network will need to meet, call themselves as 5G. 5G in India is still to come, whereas in some parts of world like China, some parts of America, this 5G is in vogue, but still on the experimental platform, where the 5G is 20 Gbps peak down rate, 10 Gbps peak upload, 30 bps per cycle peak spectral efficiency downlink, 15 bps per cycle peak spectral efficiency uplink, 100 mbps user experience download rate, 50 mbps user experience upload rate. So this is how it is much faster than 4G. And one of the most important things, which we are aligning ourselves actually, but 5G is to be still a reality for us as far as its application is concerned. So here we can see 3G, 4G cellular, how we can make it a systematic approach in the smart metering philosophy. For example, you can have the 3G, 4G modem integrated into the network mechanism. It provides a firewall for the security arrangement, and it goes to the control center. Okay, it monitors metering of remote DERs. DER is your distributed energy resources. That means that the meter shall be capable of handling the DER generated energy also. That is how this meter is known as the smart meter, which can take the load pattern in any fashion, whatever you design and whatever you desire to have. The main challenge here is establishment identify, indefinite time delay, call dropout. It affects large data exchange, high monthly fees, hence little expensive. So therefore, this is how the data for 3G and 4G platform is being identified. What is narrowband versus GSM? Narrowband, that is NB-IoT we call, narrowband Internet of Things, is a standard-based low-power wide area network, LPWA, low power wide area network. The technology developed to enable a wide range of new IoT devices and services. NB-IoT significantly improves the power consumption of user devices. Okay. New physical layer signals and channels are designed to meet the demanding requirement of extended coverage. Okay. In rural area, deep indoor, ultra low device complexity. Initial cost of NB-IoT module is expected to be comparable to your GPRS or GSM module. The underlying technology is, however, much simpler than today's GSM or GPRS, and its cost is expected to decrease rapidly as demand is increasing in a very significant manner. Supported by all major mobile equipment manufacturers, the chipset and module manufacturers, the NB-IoT, that is very important. That is, the narrowband Internet of Things can coexist with, or it can be compatible with 2G platform, 3G platform, or long-term evolution 4G mobile network. So it also benefits from all the security and privacy feature for mobile network. It provides a support, confidentiality, security, authentication, adaptability, applicability, data management, data integrity, and also it provides the safety and provides the networking philosophy with which you want to really have a management of energy. So LoRa is another thing. LoRa is short range for long range. Is a spread spectrum modulation technique derived from chirp spread spectrum, that is CSS technology. That is very important. Okay. So the LoRa is a wireless technology that offers a long range, low power, secure data transmission from machine to machine and IoT application. LoRa is based on a chirp spread spectrum modulation. You can see here the governing body is LoRa, French Alliance, standard 801.15 4G platform, frequency ISM, that is industrial standard, medicine that doesn't need license 868 915 megahertz. Range 5 kilometer urban, 15 kilometer rural. Data rate 27 kbps. Modulation chirp spread spectrum speed modulation, type based on FM modulation technology. Security 32-bit CRC. So you know what is CRC? It is cyclic redundancy check, which is nothing but a check code actually. It's a code. So this is what we have to understand in the smart meter. As you know, smart meter no longer remains an electrical technology. It is mainly focusing on the communication and also IoT and mainly the Internet of Things, particularly the uh, information technology domain with which we are talking today. I think LoRaWAN, NB-IoT. I think these three are very important. LoRaWAN is a low power IoT protocol that comprises of LoRa radio technology, allowing for an open, reliable, and economical network. Okay. So the NB-IoT is narrowband IoT, while minimizing the power consumption and increasing the coverage range in locations not served by the conventional cellular technology. This is the advantage. LoRa is the physical layer or the wireless modulation, which creates the long range communication link. LoRaWAN is about the communication protocol and system architecture for the network, as the LoRa Alliance puts. Or even simpler, LoRaWAN is the network. WAN is the wide area network. Okay. So the started range is more than 10 kilometers, between 15 to 20 kilometers. We would say typically 10 kilometers. However, there are other factors that will influence this, particularly the realistic range, such as the network, the node, gateway, the positioning, the surrounding, the environment. So many things will have an effect on the performance of this particular LoRa technology. LoRa NB-IoT is the latest in the communication philosophy. What is Z-Wave? Z-Wave is a proprietary short-range, low data rate wireless RF mesh. Z-Wave uses 908 megahertz ISM bandwidth in America, and its data rate is 40 kbps. Z-Wave provides connectivity for devices such as lamps, switches, thermostats, garage doors, where you can control the entire operation of the system. Z-Wave can be employed in the home area network of the smart grid mechanism. What is Wi-Fi? Wi-Fi is a technology for wireless local area network with devices based on IEEE 802.11. Wi-Fi is a trademark of Wi-Fi Alliance. Its data rate is 802.1, range from 1 Mbps to 100 Mbps, operates at 2.4 gigahertz ISM. So Wi-Fi is targeting home area and also NAN, FAN, BAN, etc. Wi-Fi is already being used for municipal scale networking in the environment. WiMAX, IEEE 802.16. So this uses the licensed bands. So WiMAX can provide theoretical data rate. The communication range is around 50 kilometers. It can provide long range communication for smart grid. LTE and LTE-A. LTE is your long-term evolution, and A is the advanced version. The peak data rate for LTE is around 300 Mbps. At the downlink and 80 Mbps for the uplink, with 20 megahertz channel bandwidth and 4 into 4 MIMO antenna, that is multiple input and multiple output antennas, which is a wide antenna. So this typical LTE cell has a diameter of 4 kilometers, and by relaying technique, the range can further be extended. Cognitive radio communication is another spectrum with which it is possible for us. The bands that is planned to be used are 802.22 or the ultra high frequency, very high frequency bands between 54 and 862 megahertz, and their guard bands. That is shown in the figure here. As you can see, the spectrum analysis is done on the decision making mechanism with which the smart meter is working on the philosophy. Power line communication is another important communication factor which is used actually. It has been already used in some utilities for load control and remote metering application. PLC does not have external cabling cost. It is considered to be convenient for home area, neighbor area, field area, and also for the smart grid arrangement. Broadband or power line. This is IEEE P1901. The BPL has a very high data rate exceeding 100 Mbps using frequencies below 100 megahertz. So P1901 group has selected two physical layers for the standard. Wavelet, that is orthogonal frequency division multiplexing, physical layer, and FFT OFDM based on the physical layer. So this is how the entire work on the IEEE 1901 is working. This is International Telecommunication Union, TGHN. GHN is what? Is a communication for the residential premises, offices, hotel managements, etc. So GHN is able to operate for all types of in-home wiring, including phone line, power line, coaxial cable, and Cat5 cable. So GHN can support a bit rate up to 1 Gbps. Okay. So GHN devices aim to be in comparable with the power line devices that use in the IEEE 1901 standards. ANSI is American specification. Most of the meters which are manufactured in USA will conform to this, particularly with regards to the communication. They have their own protocols and they have their own system with which they measure the entire spectrum of operation depending upon their needs and depending upon the system integration challenges. Fiber optic communication is already used in the power grid to connect utility head offices and substations. It's a lossless communication we call. Optic Ethernet can be utilized in the smart grid mechanism. It also possible for us to employ combination of the wireless and wired communication technology in the smart grid. This is how we have compared actually these standards, various standards in a simple matrix. We have here 802.154, 11, 16, LTEA, 802.22, 1901, GHN, and CCEA. Here we have the maximum ratio, data, range, nodes, scope, and we can select what we want on the optimal platform with which it is possible for us to select for the communication what we need to have in the system integrated system. Challenges in the smart grid communication is a very, very important thing, particularly with regards to what we talk today. Okay. So we talk different things, particularly with regards to the communication which we are having in the power line communication system. Okay. The wireless channels are very important. Power line communication, the disadvantages are given here. The wireless channels, they are prone to interference due to the populated ISM band, because normally this ISM band will be always busy because they will be using, the frequency, the license is not required, the population is more. Have lower bandwidth than wired communication technology. So it will not penetrate through concrete wall. Okay. So power line communications suffer from noisy channel characteristics that vary depending upon the devices. Okay. So PLC probably we will not discuss because it is known actually. So this is how the utility grid is connected in the smart meter mechanism. You have here network number 1, network number 2, network number N. And this is the substation. This is the back office, which are connected through the utility management network, what we call. So here, one particular grid, what we call a simple mechanism like a data concentrator, can handle around 300 to 400 meters, even 1000 meters also, it can handle in the DTU distribution mechanism. This is the LV transformer. This is the concentrator of data concentrator, which is mounted here, which can handle so many meters here. One concentrator up to 1000 meters, and each meter can serve as a repeater, as I told you. That is very important actually. So Zigbee is very important. I think probably is an ad hoc networking technology for low power wireless network. It intends for 2.45 gigahertz on 868 megahertz and 915 megahertz band. It costs low, complexity, power consumption as compared to the competing technology. It is intended to network inexpensive devices. So data rate touches 250 kbps for 2.45 gigahertz, 40 for 915, 20 for 860 megahertz. So RF penetration through walls and ceilings can cover 10 to 75 meters. So ability to add or remove devices and can support 32 to 255 node. Each node comprises of several hub actually. So possible with a voice support also to make it more clear in the communication technology. The domestic honeybee, what is Zigbee? Domestic honeybee, a colonial insect, lives in a hive that contains a queen, a few male drone, and thousands of worker bees. The survival, success, and future of the colony is totally dependent on continuous communication of vital information between every member of the colony. So the technique that honeybee uses to communicate newfound food sources to other members of the colony is referred to as the Zigbee. So using this silent and powerful communication, where the bee dances in a zigzag fashion, she is able to share information such as the location, such as the distance, the direction, newly discovered food source to her fellow colony members. Instinctively implementing the Zigbee principle, bees around the world industriously sustain the productive lives and foster future generation of colony members. This is how the name Zigbee is arrived at. The characteristics Zigbee, I think I have already discussed this actually. Why Zigbee? Number one, standard. Number two, power consumption. Number three, operational cost. Number four, high density. Number five, simple protocol. This is how the Zigbee based is used in the hand segment. As you can see here, this is the head end system. This is actually the web cloud. This is the end user protocol. This is house energy management system, where you have the hand and the smart meter is coming here. It may be a gas meter, it may be electricity meter, it may be oil meter, it may be any other water meter. Okay, so this is the storage mechanism with which it is possible to store, the renewable energy. So the battery mechanism, and it will provide, the necessary structure for the entire Zigbee management system and the hand segment. Okay, this is the architecture which is employed universally. Okay. This is the market application landscape. This is a matrix which I have prepared, actually taken from LinkedIn. And this is the long range, short range, low data rate, high data rate. This is public area, local area, wide area. You have from text to multi-channel. And you have here the Zigbee, Bluetooth, Wi-Fi model. And then you can get the whole picture with which it is possible to landscape the entire thing in the application-oriented system. This is Zigbee, Bluetooth, PLC comparison, where the cost is compared, the Bluetooth, the PLC, whatever is required for your optimized thing can be chosen for your application. Okay, it may be a Zigbee application, Bluetooth application, PLC application for your smart metering system. Okay, taking into account the cost, the power consumption, the data rate, the complexity, the density, the interoperability. So many other factors are there to be discussed actually, which will enhance your total structural way of thinking mechanism with which it is possible to confine to what you need to have in the system. So the communication of smart meter, I think probably what we will do is we will just go to the some case studies and then we will discuss. That is very important actually. This is the architecture deployed by Centerpoint Energy, Houston, USA. This is another early mover. They have huge number of smart meters in their system. This is they use RF mesh. Each smart meter, as you can see, it is connected in the mesh pattern. This is the DCU, data concentrated unit and gateway, and you have the BPL, broadband over power line, which is wired actually up to the substation. It goes to optical fiber and utility data center. This is how the architecture of a typical Centerpoint Energy. This is Houston in Texas, USA, and this is one of the case studies with which it is possible to make the whole system a totally acceptable, viable, adoptable system. Very important. So next is actually, this is in Enel Italy. Enel Italy is one of the distribution companies. In a big way, they have gone actually, and they have installed around 27 to 30 million smart meters so far, and they are very happy with their operation. And smart meter here, as you can see, they are currently radially connected, narrowband PLC, and you have the GPRS, you have the utility data center, which is possible for us to download the entire system into a moment of where GPRS is playing a major role to communicate with the DCU and utility data on a bidirectional platform. So this is a typical advanced metering infrastructure architecture with RF mesh as last mile. I'll tell you what is that actually. So this has emerged as a popular solution amongst utilities in many geographical area. This is IHD. What is IHD? In-home display, which is a package system which comes along with the smart meter, which is communicated on the Zigbee platform or a PLC platform. And this is wired actually in a RF mesh network. And this is the DCU. This is the gateway. And here, you have the GPRS and optical fiber, and you have the utility data center, which will give you the governance for the entire management, with which it is possible for us to incorporate the total system in an integrated solution. So this is very important. So this particular case study will tell us how important is the connection, the DCU, the way in which we operate, and also the utility data center management, how the whole system is communicable in the system operation. This is the emerging architecture for smart grid and smart city application. RF mesh canopy network is the latest trend. What is a canopy? Canopy is nothing but connected in a system module with which it is possible to have different nodes. N is actually node for any application, maybe AMI, maybe distribution automation, maybe street lighting, smart street lighting, maybe smart traffic signaling, maybe surveillance, maybe any vigilance matter, whatever it is connected on the mesh canopy. And it goes to the DCU, data concentrator unit, it goes to the gateway may be the head end system, and it goes to the optical fiber where the GPRS is there, and utility data center. It governs with the whole management with which it is possible for us to integrate into the entire mechanism. The communication architecture for next generation smart metering. This is known as IP metering. IP metering is Internet Protocol metering. Okay, so here you have smart appliance. Each appliance, for example, your geyser, your heater, whatever it is, they are all smart appliances integrated into a Wi-Fi network here. And you can see here, this is the smart meter which accepts the data from all these things, and it goes to the cloud, and finally it goes to the utility data center where the HES and MDMS is there. HES is the corporate level where you have the entire data system, and the meter data management does the entire work of data cleaning, validation. That is VEEE we call validation, estimation, etc. And then it goes to the application module. The smartphone and software application of this entire system is in the communication architecture. These are all the latest things which is taken from the internet actually, particularly with regards to the LinkedIn. We have all this data available for our total system integration. Some 2-3 case studies in 5 minutes we'll discuss actually. One is the South African system. Eskom is the distribution company which needs to perform load management among the residential, industrial consumers in order to meet the demand for energy from the industrial sector for economic growth. So the deployment of universal load controller, that is device that allows every household to apply load shedding. And Eskom does it on a broad scale. It uses the PLC technology to provide this last mile access. The approach is the distance between the substation and the distribution box at the home can sometimes exceed 1 kilometer. So the result is they have the use of the PLC communication technology and the ULC pilot to conclude the successfully incorporated in the smart metering management system in the smart grid environment to make several cities in South Africa, like Johannesburg and other cities, to make a smart city project. So this is how they have gone in detail. This is in Belgorod, Russia. In fact, here also the challenge and concept approach result very important. They also use here the PLC technology, which enables the success of AMR project, automatic meter reading project, with which it is possible to integrate into AMI system, advanced metering infrastructure. As you can see here, the whole thing is coming into the picture on the PLC networking mechanism. This is the Mexican region where it is possible for us to approach in the same system. The theft of energy is more there actually. As you can see, the entire system is accessible here in the language with which they are talking of. The challenge, the concept, the approach, and result based on the approaches. What they have concluded is use of the PLC technology will enable the success of this project. Okay, this is how they have gone in detail. A smart metering communication requirement is very important. Number one, reliability, security, efficiency, robustness, low latency, bidirectional, seamless, and based on several applications today, like IEEE, CEN, European standard, Senelec, IEC, etc. So the backbone to bridge existing and newer infrastructure is also important communication requirement. So dependability, acceptability, and also viability and optimal cost, where the technology is moving ahead, is also important for us to consider what we need to have in the project. As I told you in the beginning, one of the major things in the smart pilot project, particularly selection of a particular smart meter system, you have to have the smart piloting. So the piloting is in the Indian environment, it is happening. Some 14 pilots are active and results are coming in a big way. And where we started, no standard, legacy non-performing standard, and PLC not so reliable, RF very little market penetration. So these are all where we started. Where we stand now, that means after the pilot, evolutionary 16444 standard for smart meter is evolved. I think probably this has to be discussed in detail actually. Anyhow, PLC, that is dependable, RF canopy and mesh based, GPRS arbitration and interoperability, process design, change management, analytics, etc. are available for us to choose what we need to do and what we intend to have. So this is where this whole system is operating upon. So this is how the what smart metering system is integrated into one thing. As you can see here, these are all array of smart meter. This is the communication, and this is the head end system and MDMS, and this is the consumer interface, and this is the utility management with which it is possible for us. The smartness come from entire system component and not just one or two components. Hence, it has to be seen as total holistic structure in the design, in the implementation, in keeping end-to-end system approach. It is not the system, it is not the product, it is the system approach we should have for the smart metering. As you can see here, number one, data reading, number two, data transportation, number three, data acquisition, number four, data consumer engagement and analytics. The big data is being analyzed here in a very big way to see that how the data is validated and how it is fed to the meter management system with which it is possible to get the acquainted information for which you are intending to do the smart application in the smart city project. So I think there are some small one or two slides which I will just explain and then conclude. The smart meter. See, what is a system? System consists of meter, communication, head end system, meter data management, consumer interface, performance parameters. So these are all total system which comes into picture while we discuss the smart meter. Smart meter alone cannot be the solution. So smart meter system is the solution for the smart city and also for the domestic, industrial or large users actually. So smart meter embedded with the smart communication and also it is provided with the head end system, which is provided with the meter data management, which is provided with the consumer interface, and finally it goes to the performance parameters. That is how the whole philosophy of smart meter will be useful. Smart meter measures power in all quadrants: quadrant 1, quadrant 2, 3, 4, as per IEC 62053-23, with a communication system embedded into that. So this is how the whole system of smart meter, smart communication, smart city project, with which which is possible for us to integrate into an electrical environment to make a grid, a smart grid. How the communication plays a vital role has been discussed here. So information and communication technology are eventually becoming integrated to electrical power grid to improve the grid's reliability, grid's efficiency, grid's security, and reduce the environmental impact. I yet once again reiterate here that this health-wise, there is no apprehension about using the smart appliances. Absolutely no problem. The available communication technology can be considered as foundation for yet to emerge smart grid communication technology that will truly answer the need for the smart grid. So more research is required to overcome the challenge of communication in the smart grid environment. These are all the bibliography, which I have taken several information from these books and also these journals and also these links. So one very important message I would like to give you is I cannot teach anybody anything. I can only make you think. Today if I am successful in making this presentation to make you think, I think I am successful in getting you to the entire groove of what is known as smart atmosphere. So this is how I finished my presentation. Thank you for your kind attention, and also thank you for your time. If there is any question, I would like to answer the question in another 5-10 minutes and then conclude this session. Thank you so much for your valuable time. Very nice of you.
Hello.
Yeah.
Yeah, thank you very much, sir, for your presentation. So there are few questions are there.
Yeah.
Yeah. What is the role of transformer drum placed on a pole? I think it is not okay.
Okay, no problem. Don't underestimate any question.
Yeah.
Every question is very important for me.
Yeah, yeah.
Please.
Yes, sir,
Okay.
please.
Uh, See, whoever is asked the question, I think that's the first of one of the first slides I have shown. I have shown actually the distribution and transmission network in a grid, where the generator generates and it transmits at a very high voltage to reduce the I squared R loss, and then it goes to the distribution automation system, and then it goes to the distribution management system, from where it goes to the main houses with reduced voltage actually. And the drum type transformer, that is, it's actually to place on a pole, is a it's not it is also known as pole mounted transformer, which is very essential for using this 11 kV to 415 volts application, with which it is possible to compatible around 400 to 500 meters in a DTU system, that is distribution transformer metering unit system. That is the main purpose of that particular system, which is employed in the smart atmosphere for smart measurement. I think I have clarified this question to you, sir.
Thank you, sir.
Yeah,
Sir,
yeah, very
sir,
nice. Yeah,
sir, smart grids play a crucial role in building smart cities. Why,
yeah, yeah.
why and how?
Oh, very nice, very nice. See, as I told you in the beginning, one of the major important factors, for a smart city is smart electrical network, smart energy, smart grid, smart transportation. Okay, these are all total. More than that, more than the requirement, the electrical grid plays a major role actually for the communication system. When the communication becomes a volatile problem, for the entire system, it will lose its identity as far as the grid management is concerned. Therefore, you have to have the convergent technology to make the grid a smart grid, to make sure that it aligns with the system integrated solution for the smart atmosphere. Without smart grid, it is not possible to run several smart appliances in the smart city project, including street lighting. Street lighting is very important. Smart parking, smart transportation, smart business undertaking, smart building. So everything is linked to what is known as smart grid and smart metering application. Therefore, smart grid plays a major role in the smart city atmosphere. And to build a smart city, you have to have these basic infrastructural things which will imbibe not only the entire mechanism with which you follow the whole thing, but holistically it will have an impact on the overall scenario with which you have to have the power management in a smart manner, with which it is possible to build the smart city in a smart way.
Yeah. Thank you, sir. Next question.
Yeah.
Real-time tracking is possible from the customer point of view using smart meters.
Yes, it is possible, because you will actually integrate the whole thing on a real-time network, because it has a RTC, real-time clock. The real-time clock is synchronized to the meter actually, and meter takes the data on the real-time platform, with which it is possible to have not only real-time data but real-time analysis. That is very important. How is you consuming the load? How, what about 12 o'clock in the night, what is the pattern of load, whether the TOU is in operation, whether the TOD is in operation, all these things, it will have an impact on the overall picture, with which it is possible for the entire mechanism, with which you will notice the management system as such on the power bill, and also on the power mode, power consumption pattern, power system operation, everything, it will give information. That is how the privacy, of course, is not tapped, but the way in which you consume power is being monitored on a very, very holistic way, with which it is possible for us to make a system more a smart system.
Yes, sir. Thank you,
Okay.
sir.
Yeah.
Now, the data collected may be used by third parties. So, how to avoid?
No, 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 no. It is not possible. So you see, for example, it is protected. It is protected with a lot of security system. For example, you are using your banking system. How your banking data is not access to others unless it is protected, unless it is known, its password is known. Similar thing happening here also. The whole thing is a computational management, and you can protect. You can provide 3 or 4 way security channels, and it is not possible to use the data for any other purpose except the corporate management can access it. The user can access it with what? With security system, and the data is used for useful application only, and it cannot be violated for any other misuse data. It is not possible. And I think there is a session actually on cyber security. Probably that is another very important message, for the smart city project. The cyber security plays a major role in protecting the data, and particularly malicious data, etc. Whatever is being corrupted, it cannot go, in a heavy. It is not possible to use the data by others, but it can only be protected and synthesized by the user management system, with which the protection is done on a security coded system, and it is possible to protect the data and use the data for only better purposes of your integration or your application system on a platform with which you intend to do it actually. Okay, very nice question actually.
Sir, one more question. There is a thank you for
Yeah,
the insightful session, sir. Do they modify
yeah.
our whole new infrastructure has to be made in order to be a smart city? And do they
Hmm.
train the people to control the smart city?
Yes, yes. In fact, training is one of the most essential parameter, particularly with regards to the smart meter itself. A lot of sessions will happen. They not only because it is a new thing as such. The technology is new, application is new, usability is new, and how this particular training session will enhance them, enrich their knowledge to use it, and also to apply this knowledge usefully for the purpose of your application, what you intend to do it actually. So all these things will come in a big way as long as you use these particular things for your better purpose, particularly with the technology, new technology platform. It is possible for us to integrate the entire thing into a mechanism where you intend to learn more from these things actually. That is why they have gone what is known as the piloting. Piloting is where they learn a lot of things, in the pilot mechanism, and then they apply those things, for the roadmap, and the technology will come in a big way for application of these things. It is not one technology, it is integrated of different technologies. For example, each manufacturer will have his own technology, and each technology, naturally, it should be taught to you, it should be known to you, and you must be in a position to use it for the better purpose of the application. That is how the session is also very important. In fact, smart meter session will have different modules actually. How to calibrate the smart meter, how to test the smart meter, how to align it for the useful purpose, all these, and even billing data mechanism, and also meter data management system. These are all the special sessions are there to handle these things, in a coherent way, to make it understandable for the application of the smart grid mechanism, with which it is possible for you to understand what is happening not only with you, not only here, but also overseas. So those things are also taken for the application. So this is a good question. Very nice.
Yeah, next question. Is smart city
Yeah.
concept synchronized with IoT?
Yes, yes, very much. Very much it is synchronized with IoT. Internet of Things is a part of smart city project because everywhere, wherever you go, for example, morning we were seeing in the dump management, for the debris, even for the trash management, what they call, they use RFIDs. RFID is nothing but IoT modules actually. It is not confined to electrical engineering. It is not confined to the communication engineering. It is not confined to your information technology, but it confines to the whole overall management of the smart city project. IoT is a must. Not only IoT, but even the artificial intelligence is also coming into picture actually, to make sure that these things will have a coherence in understanding what intent to be done and what needs to be done to synchronize the whole data to your better purpose, for your better management, and for your better accuracy, for your better utilization pattern.
Sir, we'll take last two
Nice.
questions. Smart
Very nice, very
meter,
nice.
digital meter. What is the difference?
Yeah. So digital meter is not a smart meter unless it is having a communication technology with it, and also it is having an information technology with it. For example, the evolution of the meter is like this. First meter is known as 1G meter. We call 1G technology. That is the Ferrari meter, conceived 120 years ago. And over that, next meter was hybrid meter. Hybrid meter is a combination of electronic meter and mechanical meter. Then came the analog meter, that is without any moving parts. Then came the digital meter using the digital technology, like the DSP is used. Okay, and the smart meter is the latest thing, state of art technology, which may not use all these things, but it will use the total different principle of operation, like what I taught to you in the beginning. The measurement technology. It has communication module. It has the IoT module. It has the information technology module, and then it has the switch mechanism with which it is possible to control the load. All these things. So therefore, digital meter is different. Smart meter is different. Smart meter is a meter which can communicate. Smart meter is a meter which can understand your load pattern. Digital meter just measures the energy, and that is all. Whereas a smart meter will give you the entire information, whatever is needed, for your information mechanism, with which it is possible to concentrate more on load management, energy management, and also the system with which you can integrate the whole thing into a mechanism where it is possible to align yourself to the latest technology trends. Smart meter is different and digital meter is different. Okay.
Okay.
But digital meter upgradation is the smart meter. Okay.
Okay, sir.
Reverse is not.
Sir, smart meters installation in UP has been stalled
Yeah, I know that.
because of some
I know.
glitch. So what was the reason?
Yes.
Nearly
Yeah. In
40
fact,
lakh meters has been stalled.
yeah, yeah, yeah. Actually, this is where I have a lot of information. Just I was just going through the Google information with regards to the smart meter in UP. In fact, there was a hacking possible, for the entire metering system, the data management system, what they call. They have a corporate level, they have a utility level, they have the management level, with which it is possible to integrate the whole data into the systematic approach with which it is possible to manage the entire mechanism to confine the whole thing into one realistic mode of operation. So one array of meter in a particular packet of UP area was hacked actually by the third party. So this has caused some problem with regards to what is known as the security of the system. But incidentally, the manufacturer took several bold steps, and then he has protected the whole system by what is known as providing, a security system module with which the whole mechanism was concretized in the sense, it was synchronized with the main system, and the whole data was available not only to the system integrated level but also to the corporate level, so that what is happening in the meter could be retrieved. In the UP area, so the meters were supplied by EESL, that is the Electrical Efficiency System Management System, EESL. So they have supplied these meters actually for their incorporation. In fact, about 10 million smart meters are in use, and now they have reversed the whole thing, and the whole meters are in operation, and the energy efficiency has increased, the billing also has increased, the productivity has also increased, and then now it is possible for them. They have confined themselves to the system wherein it is possible to give the entire information in a manner which is possible to integrate them into the holistic platform. So it is not a threat actually, but it is an experimental thing. And now they have recovered the whole thing, and then it is possible actually by the communication technology and also by the internet mechanism and also by use of what is known as cyber security to stop the whole thing and then protect the entire operation in the UP area. So this I have read it recently. Also, I have read that article, and if you want, I will just share that also to you so that you
Yeah.
can submit to the participants. There are some materials also I have, so I can share with that will have this information on the UP arena.
Yeah. You can share it, sir. So thank you very
Yeah,
much, sir.
yeah.
So Rashmi madam, do you have any question? You raised your hand. Just 1 second. Okay, I think
Yeah.
it is not there. Okay, sir. Thank you very much, sir. So before
Yeah.
ending this meeting, so request our faculty member Monica madam for vote of thanks, madam. Over to you, madam. Just
Thank you so much. Yeah.
Thank you very much, sir. The challenges in communication technology for incorporating smart meters to be employed in smart cities is a very hot area where we all have to be knowledgeable about it. And you have given the gist about the topic. Expect you to be looking forward for your constant support and information regarding this, sir. Thank you very much, sir.
Thank you so much. Very nice of you.
Okay, thank you very much, sir.
Thank you.
Sir, if possible, participants are requesting for your presentation. If possible, you can share it, sir, with me.
So presentation may not be possible, but I will share some materials as I
Yeah,
told you.
definitely, sir.
That is enough.
Definitely.
The reading
Definitely,
material
sir.
I will give that actually by evening. I will just mail it to you.
Okay,
You
sir.
can share with everybody
Yeah,
because
yeah.
this presentation cannot be shared.
Okay,
Because
thank you,
of
sir.
the
No problem. No problem. Not an issue. So thank you very
yeah,
much, sir, once again.
yeah, very nice of you.
We'll keep in touch with you for our future activities, sir.
Sure, sure. Thank you so much.
So thank you, sir. Thank you all the participants. Tomorrow we'll meet at 10 a.m. So I will end the meeting now.